We will now look at the final section for section 3.1, relations and functions. Our example asks us to determine the domain of the following functions. Remember that the domain is the set of x values. Quite often it is easier when you are determining the domain to find out what numbers might be a problem, or to find out what numbers can successfully be plugged into the function. So let's think about potential problems for part A. Part A says f of x is equal to 5x minus the square root of 3 minus x. Now I know that the 5x is not going to be an issue because I can plug any number in for x and get a number out for y. There should be no restrictions on what I can plug into the 5x. However, the square root of 3 minus x could potentially be a problem. For example, if I were to plug in an x value of 5, so let's suppose that x is equal to 5. Look at what happens in that case. We would take our function, and where there's an x, I would put a 5. So I'd have 5 times 5, which again we knew was not going to be a problem. And then we'll have the square root of 3 minus 5. So 5 times 5 would be 25. And then we would have the square root of negative 2. And in the real number system, this is a problem because we cannot take the square root of a negative number. So 5 is not going to be an acceptable value for the domain. So what I need to do is I need to figure out what values are acceptable. So what I need to be sure about is that when I plug in underneath that square root, I need to be sure that the expression 3 minus x has to stay positive. Because if I plug an x value into 3 minus x and it becomes negative, then I'm not going to be able to take the square root of it, and the function is not going to be defined. So I need 3 minus x to be positive. So mathematically, that means that the 3 minus x needs to be greater than 0 in order for it to be positive. Greater than 0 indicates that our answer would be positive. And not only that, but it's possible that it can equal 0. So I'm going to go ahead and put the equal to underneath. So let's solve that inequality. So I am going to, first of all, subtract the 3 from both sides, which is going to give me negative x is greater than or equal to negative 3. And then I'm going to divide both sides by negative 1. Now remember that when you're solving an inequality and you divide by a negative, you have to turn the inequality sign around. So this becomes x is less than or equal to 3. And so those are the values for which that part underneath the square root will stay positive. Now we can write this with interval notation, which means that our domain would start with negative infinity and go all the way to 3, including the 3 because of the equal to. So this is the set of all numbers that are less than or equal to 3, and this is an acceptable way to write your domain. All right, so let's look at part B. For a fraction, the potential problem occurs in the case that the denominator equals 0. So we want to be careful with that. We want to be sure that the denominator of the fraction cannot equal 0, because if it does, then we can't divide by 0. The fraction becomes undefined. So let's look at where that happens. Where does x squared minus 1 equals 0, because we definitely want to exclude those points. So we can solve that expression for x by adding 1 to both sides. So that gives me x squared is equal to 1. And then taking the square root of both sides of the expression. Now remember that when you take the square root of 1, you get positive or negative 1. So our domain is going to essentially be everything but positive or negative 1. So let's think about what that's going to look like in interval notation. All right, and it may help you to think about a number line real quick. We're going to exclude the 1 and the negative 1, but everything else is going to be okay. So I'm going to start with negative infinity, and I'm going to run all the way up to negative 1, but I'm going to use a parenthesis here because I don't include the negative 1. Then for this middle section, it's going to start on the other side of negative 1 and continue until we get to 1. Again, not including the 1. It's going to skip the 1 and start on the other side of 1 and go to infinity. And we are going to put a u, and I did not leave room here. We're going to put a u in between each of these to indicate that these sets are unioned together to represent the domain. And so the domain of our expression will be from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity.